Well, hello. This is lesson 61, and this is some advanced factoring. So we have talked about factoring. You always take you look for a GCF first. That's always the first thing to do. And then if you have a binomial, after you've done the GCF, if you have a binomial, the only one that does anything that goes factors even more is the difference of squares. Okay, so we've done those, and we've done, if it's a trinomial, we have just said, hey, what multiplies to C but adds to get B? Or if our A at the very beginning was larger than 1, then we use the box. So today, we have all that stuff knowledge in our head, but now we're going to go into a little bit different ones. So far, we've talked about, let's just do a couple of the difference of perfect squares. So you're like, okay, what? That's a perfect square. It could be x and x, and that's a perfect square. It could be 4 and 4. So the difference is when it has a subtraction. So x can be split up into x and x, and the negative 16 can be a positive 4 and a negative 4. And there you go. Okay, this next one, I can't quite do anything yet, but we got to look for GCF. There is, so we should be able to take out a 3 first, right? So I've got this. Now I'm left with a binomial. Is that a difference of perfect squares? Yes. So that separates into x plus 2 and x minus 2. There you go. Okay. Hey, I would, starting today, I would definitely be taking notes because you will have questions to fill afterwards in a Google form about these notes. I need to make sure that you guys are watching these before you try jumping right in and getting confused on the homework and it's taking too long and it's too hard for you just because you didn't want to take time to listen to my beautiful, wonderfully written notes. Okay, so here we go. This is the new stuff. The sum and difference of cubes. So now we have some kind of numbers, the binomial still, but now both things are cubed. Now, it doesn't matter if you have a binomial and both the first and the second one are cubed. It doesn't matter if you have plus and minus. Okay? So it separates into these two. Right. Highlight these down, please. Please. The difference between these two signs right here and these two signs are the difference between the two. Okay, so if we look at this first example, so is d cubed, is that a perfect cube? Yes. I'm going to write A is D. I'm going to figure out what my A, like what it is that I can cube and get that. And B, what do I cube to get 125? 5. Okay, so now I have the A and the B. I'm going to go and put that into this first equation. So D plus 5, and then A squared, which is D squared, minus A times B, plus B squared, which is 5 squared, which is 25. Okay, so on these, it's a little more challenging, as you see in just a second, your A's and your B's, and so I tend to write those down first. That's just a preference of mine. Okay, so let's go to this next one. So we look at this one. Okay, it's a binomial. Do I have a GCF? No, there's no number. There's no variable. There's nothing that can come out of both terms. So is this first one a perfect cube? well, 8 is 2 cubed, right? And x is 6 is really x squared cubed. Okay, so there's my A term. My B term is, okay, 27 is really 3 cubed. And then y cubed is really just y, right? Okay, so this I'm just going to rewrite up here. Ooh, a squared minus ab plus b squared. Okay, so I'm going to put a, 2x squared, plus b, 3y. Okay, this was where it gets a little bit more challenging. Okay, it's a squared, so it's really 2x squared, that's a squared, minus these two multiplied together. If I multiply them together, it's 6x squared y, and then my b squared. So if I want to simplify that, what's 2 squared? 4. And something, a power being raised to a power, you multiply. So that's 2 times 2 is 4. Okay, and then 3 squared, which is 9, and y squared. There you go. There is your answer. Okay, these definitely are a little bit longer than your difference squares. Okay, but it's just putting them into an equation. So if I look at this next problem, I say, okay, is there a GCF? Yes, what can come out of both of these? They're both even, and they have two m's that can come out. So I'm left with m cubed minus 125. That's it, right? Okay, now is that binomial, is it anything perfect? Is that a perfect cubed? What cubed? And is this a perfect cubed? Yes, 5 times 5. Okay, so I'm going to write, you guys could flip back and look, but here's the equation. Okay, so this 2m squared does not go away. It travels with us. It's just going to be out in the front of everything. So a minus b, which is m minus 5, a squared, which is m squared, plus multiply a and b, which is 5m, and then b squared, which is 5 squared. That is my answer. That one's not too bad. Okay, so let's go on to some different things. I may come back and try to do one more that was similar to the one in red above that at the very end, if I remember. Okay, so let's do some factoring by grouping. I think some of you guys have seen some of this, and so it might come quickly to you. So we've talked about binomials, we've talked about trinomials. We have not talked about any like factoring of anything larger than that, except just like a GCF. This is, it's got 4 terms, right? So if it's got 4 or 5 or 6, 4 more, then you can group them and factor by that. So you take the first 2, you kind of split in half. That one looks like a, there you go. So what you do is you go, okay, look at these first 2. Is there, and then kind of like factor each of those. Is there a GCF out of that? Yeah, I can take an x squared out. I'm left with the x and an 8. Okay, I have a plus sign, so plus sign. Is there anything I can take out here, GCF? Yes, a 2. I should have x plus 8. Guys, when you're factoring by grouping, these two right here better be the same. If they are not the same, then you did not factor the correct GCF out. Like you need to go back and try it again. Okay, so what you do from there is you take these two on the outside, and that becomes one of your binomials. And then you take, there's these two, you just take one of them. And that right there is your answer. If you were to multiply this out, if you were to FOIL, you would get first, outer, inner, last. You're going to get exactly what you start off with. See? So you factored correctly. Okay, so let's check the next one. I'm going to cut these in two. Kind of be careful about that minus. Okay, so I look at the first and I say, okay, is there a GCF out of these? Yes, I can take x cubed. I have an x left and I have a 5 left. I have a minus. Is there anything I can take out of these two? Yes, an 8. I guess I should have kept that. Kind of made that with, I should have taken out negative 8. Okay, so again, those better be the same. If not, start over. So that is one of your answers, one of your parentheses. And then whatever's on the outside go together and become the other binomial. There you go. If you were to FOIL that one out, it would get you what you start off with. Okay, now, factoring by grouping isn't that bad. This one's a little bit bigger. Let's see. Okay, so there's 6 terms. I'm going to cut in 3s. Okay, so that's my first group. That's my second group. So I take the first one and I say, hey, can I take anything out of all 3 of those terms? Yes, you're right, x to the 4th. So I have x squared left, I have a 5x, and I have a 6 left. Okay? Now I say, is there anything that can come out of these? No. So I'm just going to kind of rewrite that. Well, okay, if nothing comes out, what do we know that definitely comes out? A 1. If I took a 1 out, nothing happened, right? Nothing changed. So are both of my sets of parentheses the exact same? Yes, and that's what I need them to be. So I'm going to write that down once. And then the things on the outside are going to become my other set of parentheses. Okay, so I'm just going to kind of look to see if I have any more. I'm left with a trinomial. That's not normal. Can I do anything with that trinomial? Can I factor it? Yes, I need to factor it. So what multiplies to get 6, but adds to get 5? 5 and 1. Now here's a binomial. Is this a difference of squares or difference or sum of cubes? No. We cannot do anything else with it. Again, if I was to multiply all 3 of those, I would get what I started off with. Okay, so I'm going to go and let's do this bottom one here. There's only 4 terms, so I'm going to split it up into 2 and 2. So the first one, anything come out? Yes, an x cubed. So I have an x and a 4. Anything come out of these? It's starting with a negative out in the very front. I do not like the first term to be negative, so you always need to take out that negative. Is there anything else? No, so we need to take out the 1. So we're left with x and a plus 4. My 2 terms look the exact same. It's great. So I copy that down once. And the 2 terms on the outside become my other one. So I'm going to look. This binomial, is there anything special about it? No. Is this binomial, is there anything special about it? Yes. It's a difference of cubes. Our A is x, and our B is what number cubed? Got you that? 1. Okay. You can go back to your notes to look, but I'll go ahead and set up. So I know this x plus 4 is definitely going to go out. So I'm going to go ahead and write that. Now, my equation says difference of 2 cubes is a minus b. So, x minus b. Then it's a cubed, or sorry, a squared, which is x squared. And then it's plus ab, so a times x times 1 is x, plus b squared, which is 1 squared. So you got. Now, can I go any further? I cannot. I cannot, here's a trinomial, but I can't multiply to get 1, but add to get 1. There's nothing there. So I am finished. Okay, again, I'm going to write that. Let me. Was a plus b, a squared. Okay, I think I need a negative sign there. Oh, it's going to erase it all. It's a minus b so that's where I got this. Okay, hey, like I said, I'm going to go and do one more of the ones at the very beginning that were in the red. Let's look at 27 x to the 6th plus y to the 9th. So, okay, first, is there a GCF? No. Is this it's a binomial? Is it difference of squares? No. Is it a difference of cubes? Is it a number cube that gives you 27? Yes, 3. And x to the 6th can be x squared cubed. Okay. And is y to the 9th cubed? Yes, it is y to the 3rd and then cubed. Okay. So, again, it is a plus b, a squared minus ab plus b squared. So our a is 3x squared, our b is y cubed, a squared is 3x squared minus, and multiply these two. So that would give you what? 3x squared y cubed. and then it's b squared. So that gives you 3 squared, which is 9. X multiply, so 2 times 2 is 4. Okay, so, and then a power raised to a power you multiply. So you are done. Okay, so I wanted to do one more example of that for you guys. Okay, I'm going to close up 20 minutes. I want to go any longer than that. Okay, please go and fill that Google Forms, and then there's an assignment on IXL. Thank you.